Like you said, the third thing we're doing is hyperbola. We're good. It'll take us 2 days to do that, and then we'll review Wednesday. Because it looks like chapter 10 test will be on Thursday. There's only 3 sections, so it's not quite as worth as many points. So 60 to 80, right around there for Thursday. And that'll be the last grade for the 9 weeks, or for other than I got to do your homework grade. Oh, for your homework grade, I always say I drop your lowest one. I'm going to do that today or tomorrow. After that, anything can't be dropped. Okay, so like any homework assignments after that will automatically be counted. So for whatever reason you don't get one done, it'll count as whatever that grade is, 0, 5, or whatever. Okay, so I will drop your lowest grade here today or tomorrow. That way you'll know what you're working with. And then, like I said, everything after that can't be dropped. All right, we're going to define a hyperbola, talk about graphing it, and what's something new is what's called asymptotes of a hyperbola. All right, here's the basic case there. It's going to look like that first one here. We'll get to that definition in a second. This will still have foci. Okay, an ellipse had 2 foci. Hyperbola has 2 foci. Parabola has 1. Okay, focus. Standard position, that's at negative C0. That's at C0. The origin would be what you call the center. Okay, because it's basically going to be equidistance from the center. The 2 parts of the hyperbola are called branches. Okay. Branches can either open left and right, or they can open up and down. Okay, they can open either way. Okay. All right, here's your definition. Okay. Hyperbola is the set of all points. Okay, and all these are based in a geometric definition. Set of all points. The difference, okay, the difference of whose distance is from 2 distinct points is a constant. So you are subtracting. Your 2 distinct points are your 2 foci. So this C value here and this C value here, if you take any point on the hyperbola, those 2 distances, call it D1, D2. And it's always the absolute value, because depending on whether you take the bigger one minus the smaller one, or then you get a negative. So the absolute value would be the same, or if you take the bigger one minus the smaller one, it would be positive. So if I take D2 in this case minus D sub 1, that's going to equal, it's always going to equal 2A. So 2A comes back again. So that's going to be the case. So in any case, D1, the absolute value minus, I could probably just do it this way, equals 2A. Absolute value will always be that. Let's see. Transverse axis. That is what, in this case here, it is y equals 0. It is what goes through your foci. A will be your vertices. Okay, in terms of that. Also have what we call asymptotes. And I'll show you how to get those. But the hyperbola will go along the asymptotes both directions. Okay, anytime you got an asymptote, it will follow that line out to the left and out to the right. Then you got your center. All right, like we said, transverse axis is horizontal. That means it opens left and right. Here's your general form. If its center is not at 0, 0. This case here, for a ellipse, it was a plus. For, hyperbola is going to be a minus. You're always going to be subtracting. The negative part is the y part. It opens left to right. Okay, and here's the way I think about it. It opens along the x-axis. So if my x part is positive, it's going to open left and right. Center, HK, slopes to the asymptotes, B over A. Okay, I like to think rise over run. And when I say rise, what is underneath the y piece divided by what's underneath the x piece. So right there, this is b squared, square root of that, over square root of a squared. If it's at center 0, 0, x squared over y squared minus y squared over b squared. We said the constant difference is 2a. c squared equals a squared plus b squared. What was it for an ellipse? It was a squared minus b squared. Okay, so you got to be careful. Keep these things straight. Let's see if there's anything else. All right, now for an ellipse, we always said a squared was which number compared to b squared? In terms of how big the number is. A squared was always the bigger number. Not true for hyperbolas. Got it? A squared is always underneath a positive piece. Okay, so now as you take a look at this next one, if the transverse axis is vertical, which would be x equals 0, a squared goes underneath the y minus k squared. And then the negative piece is the x part. A squared could be smaller than b squared. It doesn't matter which one's bigger. A squared is always the one underneath the positive piece. B squared is underneath the negative piece or whatever you're subtracting. So this is how you figure out whether it opens up or down or left and right. Your C value, your foci have to be inside the branches. Okay, they have to be inside the branches. Slopes of the asymptote. All right, what was you got it right there on your picture, on your notes. Up above, the slope of the asymptote was B over A, right? What's it now? A over B. Like I said, I'm going to tell you to go rise over run because underneath the Y is now A, underneath the B, or underneath the X is B. So if you think about that, I think you're not trying to memorize which one it is. You just like normal. Whatever's underneath the Y, you go up. Whatever is underneath the X, you go down. Let's see here. Vertices A and A. Now there's also B value, and I'll show you how that comes into play. All right, let's just jump into it. This bottom one, we're going to graph that. Find the center, find the foci, find the vertices, sketch its graph, including the asymptotes. Now both pieces count as the graph. Both pieces are part of the graph. First thing you want to identify, which way do the branches open? Do they open up left and right, or do they open up or down? And use the right above you to help you. And it has to do with which piece is positive and which piece is negative. All right, the X part is the positive one. Okay, looking at that, which way do you think that's going to open up? Like Luke Hirschberger, what do you think?
Would it open right?
Well, left and right.
Yeah.
It's going to open up both ways. Both ways. It's either left and right or up and down. Parabola could be one or the other. Hyperbola has two branches. And so both branches are part of the problem, or part of your solution. All right, so it's going to open up both directions. Where is its center at? Where is its center at? Okay, so you take a look at that. Colton, do you know?
1, 0.
Good. Our center is at 1, 0. Center's at 1, All right, which one's A squared? Which one's B squared? Ashton, what do you think?
A squared is 4, B squared is 9.
Good. A squared is 4, whatever's underneath the positive piece. A squared equals 4, which means A equals 2. B squared equals 9, which means B equals 3. All right, what about C then? That's where my foci is. So C, well, what's the equation for C squared? For both of them, C squared equals what? A squared plus B squared. All right, so C squared equals A squared plus B squared. So that means C squared. Now A squared is 4. B squared is 9. So I get C squared equals 13. C equals square root of 13. All right, now what else do they want to know? All right, we got to sketch the graph including the asymptotes. All right, now I'm going to do this way. I'm going to start with the center. Center's at 1, 0. So start with a point right there. All right, the slope of the asymptotes. They go through the center. Let's see if I can go backwards. Okay, the asymptotes right there go through the center. Now, we said it's left and right. What are the slopes of the asymptotes? It's going to be what? B over A. And we're actually going to draw these in first. Now, B over A, in this case here, I do rise over run, make sure you take the square root. So it's going to be slope of the asymptotes. We're actually going to find the equation here in a second. But the slopes will be plus or minus 3 over 2. Rise over run. Whatever underneath the y over whatever underneath the x. All right, so start at your center. Go up 3, we're going to make a box. You don't see this on the graph, but we're going to do this. I'm going to go up 1, 2, 3, and I'm going to go to the right 2. I'm going to go up 1, 2, 3. I'm going to go to the left 2. I'm going to put a dot. I'm going to go down from the center 1, 2, 3. Go to the right 2. I'm going to go down 3 and go to the left 2. And I'm going to make a dotted line here. I like to make the actual box. Some people just leave the 4 corner points. That is how you draw in the asymptotes. They will go from corner to corner through the center. Okay. So you're going to go down 3 over 2 and up 3 over 2 both directions and make a little rectangle. Now I'm going to draw in the asymptotes. And so it's going to keep that same slope. So down 3, so you can go up 3 over 2 from there. And I'm going to just extend that a little bit. All right, go ahead and draw that in. I'm just going to wait, be patient here. That's not, remember, this is not the actual hyperbola. This is not the actual hyperbola. That is just helps us to orient it. All right, from here, to get the vertices. All right, look up above at the top. Where are the vertices? How far do we go to get to the vertices? You go whatever that A distance is, left or right. And it should be on the box. So my vertices, I'm going to go left or right 2. Right there and right there. Those are my vertices. And that's going to be -1, 0. And 1, 2, 3, 0. The foci, you go square root of 13 left and right as well. You remember it's going to be contained inside the branches. Well, you're going to have to estimate what square root of 13 is. Okay, it's approximately what? 3.6, approximately 3.6. So I'm going to go 3.6, 1, 2, 3.6, and put a mark. 1, 2, 3.6. So now when I'm listing that, the foci will be, all right, it's normally the center's at 1, so you're going to go 1 minus square root of 13, comma 0. I'm going to go 1 plus square root of 13, comma 0. So I got that. All right, now we're not going to plot any other points. The vertices are the key points. Here's what's going to happen is for your branches, it's going to open up left to right. It's going to go towards the asymptotes. It's got to hit at that one vertex, and then it's going to go along each of those lines. So it's going to look just like that. And then this here Oops. So there's your graph. Okay, open up left and right. It's that vertex, each vertex, and it goes along the asymptotes. Okay. One thing we also need to get is the equation of the asymptotes. And we're going to do them both at the same time. Okay, equation of a line. We're just going to go the old y minus y sub 1 equals m, the slope, times x minus x sub 1. Both lines hit which point? Both lines hit which point? Center. Both lines go through the center. The center is the point 1, 0. The slope for one line is positive 3/2. The slope for the other line is negative 3/2. So what I can do is I can just put plus or minus 3/2. So this is going to look like y minus 0 equals plus or minus 3/2 times x minus x sub 1, which is just a 1. Now, if you got that, you can drop the y minus 0, just make it y. So you would have y equals plus or minus, man, this thing's acting up, 3/2. You don't have to distribute. You can leave it like that. Usually from here on out, a lot of times you just leave it in that point slope form. All right, so there's your equation of the asymptotes. Understand there's two different equations. You can leave it like that. That's absolutely fine. I just want to make sure you understand that that is the same as y equals positive 3/2 times x minus 1. And it's the same as y equals negative 3/2 times x minus 1. Those are the two different lines. Okay, so you're going to have hyperbola open up left and right. All right, a little bit more going on here because you got to deal with the asymptotes. All right, flip it over. All right, for the second one, we're going to do the same thing. We're going to find the center of foci vertices, and we're going to also find the equation of the asymptotes. So copy down that one there. All right, first of all, figure out which way it opens. Does both branches left and right or up and down? All right, Tim, any ideas which way it opens?
Left and right.
What makes you say that? Or are you just kind of guessing? Okay, go to the front. Flip it over to the front. Here's how you tell the difference. Okay, it has to do with the positive piece. Okay, which one is it positive and we're not subtracting? Okay, so in each case, the positive piece is different. So for the ones that open, so this one here is x minus h squared. So the x piece is positive. In the second one, the y piece is positive. Which piece is positive for the one we just did? For on the back.
The x piece.
Flip it over. Which piece is positive? The y piece, which means it's going to open which way according to this? Up and down. Okay, so since the y piece is the first one, that's the positive one. Okay, this will open up and down. Okay. Center, Ryan Hammer. What's my center going to be?
1, 0.
1, 0. No, not 1, 0.
Yeah, 1, negative 3.
1, negative 3. Good. Center will be 1, negative 3. Okay. A squared is the number underneath the positive part. That is 25. B squared is the number underneath the minus part and the negative part. It's 4, which means A is 5, B is 4. The slope of the asymptotes, we'll do the equations here in a second. The slopes is plus or minus rise over run. What's underneath the y? Think, rise is always the y coordinate. So it's always that square root. So it's going to be plus or minus 5 over 2. And so I'm going to go to 1, negative 3. Okay, and that's going to be your center. And now from there you go up 5 over 2, and we're going to make a little box. Go 1, 2, 3, 4, 5 over 2, and then I go 5 to the right, or up 5 to the right 2, to the left 2. Okay, some people just leave that, drawing your asymptotes from there. That's fine. I like to draw in the box just to have a reference. Let's see, this will stay red. And go ahead and draw in your asymptotes. Let's see. All right, now I don't have a lot of, whoops. Room down below here. But that's fine. And extend it just a little bit. All right, what's going to be those equations? We can might as well come up with those now. Equations of those lines. Because we know the slope, and it contains the point 1, negative 3. So my equation is going to be y minus y sub 1 equals m times x minus x sub 1. So it's going to be y minus negative 3, which becomes plus 3, plus or minus 5 halves, x minus 1. And you can leave that. We're done. Got your equations. That gives us both lines. All right, now to graph it, the A value, that tells you how far to go from the center to get the vertices. So you're going to go up 5 from the center, and it should be right on that box. That's why I like drawing that. And I can go ahead and graph in the hyperbola from there. So my vertices are, what are those points? That is 1, 2, 1 positive 2, and 1, what was that, negative 8? Negative 8. All right, what's the last thing I need to find? Foci. Last thing I need to find are the foci. So what's actually, determining these points is your foci, because that's where that distance. Now remember, your distance is 2a, which would be 10. So let's see here. My foci, we got to use c squared equals a squared plus b squared. So c squared equals 25 plus 4. C squared equals 29. C equals the square root of 29. So you're going from your center, square root of 29. What is that going to give me? What is it? 5.4? All right, good. So square root of 29, Brian said, gives me 5.4. So I'm going to go up 5.4. 1, 2, 3, 4, 5.4. And I'm just going to put a mark there. And so my foci, I'm going to do this. It's going to be 1, negative 3 plus square root of 29. And then 1, negative 3 minus square root of 29. Okay, for that. So any point, the difference, and I wouldn't draw this on yours because I can erase this. So if I pick a point here, the distance to that focus and the distance to this focus, D1 minus D2 would have to be 2A, which is 10. Absolute value of that. So that would be 10. Okay, that's how you generate that. I'm going to get rid of that. And I don't want that on your final one, but I just wanted to demonstrate it. Okay. All right, we're just going to do this third one here. We're not going to end up doing all of them. Now you're going to see something like this. All right, obviously it doesn't look anything like the others. And it's kind of like with ellipses, we're going to have to make it into that form. How do you tell the difference between this and an ellipse? Okay. If it was an ellipse has both the x squared and the y squared are positive. If one of them's positive and one of them's a minus, it's got to be a hyperbola. We want to put the positive piece first, which is the x's. Since typically that's how it's written. So I'm going to put 9x squared, and then we're going to have to complete the square. 9x squared minus 18x. I'm going to put that first. Minus 4y squared minus 16y. Move the 43 to the other side. So it becomes a positive 43. All right, working two at a time. Just working with the x's first, and then we'll work with the y's second. Factor out the 9. And that will give you x squared minus 2x. This is where we put in our spot to complete the square, plus that blank. All right, factor out on this next one a negative 4. Factor out a negative 4. So it's going to become minus 4. And then when I do that, divide that one by negative 4, and it'll become a plus 4y on the inside. Put a blank, and then I got 43. And then I got 2 blanks there. Now, fill in where I need it. Half of negative 2 is negative 1. Square it, you get a 1. 9 times positive 1 is 9. Half of 4 is 2. Square that, you get 4. All right, what goes up now? Be careful here, because you have a negative 4 in front. Negative 4 times 4 is negative 16. What should go on the other side? It's got to be a negative 16. Okay, it's got to be the same thing. So we're going to have a negative 16 here. Now we got 9 parentheses, x minus 1 squared, minus 4 parentheses, y plus 2 squared, equals, what do we end up with there? 36? 36. All right, divide by 36 because it has to equal 1. Divide by 36. I get x minus 1 squared over 4 minus y plus 2 squared over 9 equals 1. All right, so now it's in the form we need. We can find your standard vertices, foci, equation of the asymptotes. First of all, which way does it open? Take a second and you need to look at the front. Look at the front. All right, Andrew, what do you think? Which way is it open?
Left and right.
It's going to open left and right. Good. My center is going to be 1, negative 2. A squared equals 4. A equals 2. B squared equals 9. B equals 3. Okay, slope plus or minus what? I'll give you a second to catch up. What you think about the slope? All right, Luke Candle, what do you think about the slope?
Is it 9/4?
Take the square root of those. It's always going to be those. That's going to be your a squared and b squared. So you always get it's going to be a over b or b over a. So you take the square root of those values. So instead of 9/4, it'll be 3/2. So it'll be plus or minus 3/2. All right, so I'm going to draw in my box. I'm going to draw my asymptotes and write the equation here in a second. So my center is 1, -2. And now you're going to go up 3 and over 2. And you're going to form the corners down 3 over 2, down 3 over 2. Okay, draw in that. And I forgot to draw in the box. So it goes up 1, 2, 3. Okay, there you go. We said it opens up left and right. A tells you how far to go from the center left and right. So I'm going to go 2 from the center left, 2 from the center right. Actually, let me get rid of that. And I can draw it in at this point, and then I'll figure out the rest here in a second. So to hit that vertex, go along the asymptotes. Like that. All right, vertices. Well, let me go with the equation of the asymptotes first. So the equation, and it goes through the center. So let me put that down, 1, -2, and we're going to use that slope. So we got y minus y sub 1 equals m times x minus x sub 1. Y plus 2 equals plus or minus 3/2 x minus 1. And then lastly, the foci, c squared equals a squared plus b squared. C squared equals 4 plus 9. C squared equals 13. C equals square root of 13, which I believe was 3.6. 3.6. So I can go 3.6 to the right and 3.6 to the left. And we just need to list the vertices and foci. So then we'll be done. So vertices. What is that? 3, -2. Well, let's start out with -1, -2. 3, -2. And then my foci. That's going to be 1 minus square root of 13, -2. 1 plus square root of 13, -2. Okay. All right. A lot going on. Because you're adding in those asymptotes. C squared equals a squared plus b squared, whereas opposed it was minus with the ellipse. So some subtle differences. A squared is not always the bigger one. That's only for ellipses. Okay, so you're going to need your notes here probably for the first few. All right, page 982. You got to graph all of them. Okay, just those 4 problems. Do them on graph paper if you got it. If you don't have it, then you got to be really neat. I'm going to look over what you turned in today. Aye.